Kia ora. Welcome to our video today, which is exploring how to write simple step-by-step algorithms using the Dinosaur Loops kit. As you can see, the board has been set up and it can be arranged in any direction or any positioning based on, as long as it creates a grid for Explorer Ed to move around. You can see that there's a start position on there, there's a finish position, and I've decided to place some eggs on there that Ed's going to go around and collect. If you want to, you can put dinosaurs in those positions. It's entirely up to you. When students first start out, I advise just having the start and finish flags on here rather than having things for them to visit or collect. Now in Dinosaur Loops, you will see that it's a little bit different to Dinosaur Steps. In Dinosaur Loops, we start to introduce things like direction. And so Explorer Ed now actually stands up. As you can see, Ed has a stand and can face in a certain direction as we're programming. So what we need to do is, before we actually start to plot a path or to write an algorithm, we need to decide which way Ed is facing. And we can show this by using the yellow arrow card with Ed on it. So essentially we can have Ed facing any direction to start off with, but we need to make it clear to the students which way Ed is actually facing. If Ed faces to the right or faces downwards, then those are quite easy starting positions for students to begin their plotting of their path. If Ed is facing the opposite directions, then it makes the start a little bit more complicated, and so you need to have a little bit deeper thinking. For now, though, we'll place Ed facing in this direction, which means that Ed will start in this position in that particular square. The next stage then is to actually plot the path. And we know that using the footprints, we can plot the path step by step by step. Now, this is an extra step in a process for coding and programming. It's been designed to help the students to really think critically about where they're going to actually plot the path through. So are they going to make the most efficient path or the fastest path? Are they going to be able to dodge any obstacles if you wanted to add those in there, for example, erupting volcanoes or bubbling mud pools? And so you can see that there may be more than one solution to the problem, and this activity encourages the students just to choose one of them. So I'm going to plot the path by placing the footprint cards into the squares themselves. Once we've visited the eggs, I can then select and choose the direction to go to get to the finish, as you can see here. Once we've then plotted the path, what we're going to do is start to think about how Ed is going to receive instructions to actually get Ed from start to finish. So this is where we have the command cards, and these once again are different to Dinosaur Steps. In Dinosaur Steps, we just had the blue cards, which meant that the students moved a whole square. Now in Dinosaur Loops, we are now bringing in rotation, so rotating around 90 degrees or a quarter turn. And so in this case, if we use the blue arrow, that means that Ed is going to move one whole step forward. Okay, so one whole step forward. If we use the green arrow, this now means that Ed is going to go one whole square backwards. Now, if we use the right turn arrow, what that means is Ed now stays in the square and rotates 90 degrees. Ed does not move across into another square. The only way to get Ed moving to this next square here is by then following with a blue arrow command, which means move forward. Same as if we want to go in the opposite direction, we actually get Ed to follow those around. So, considering the different commands that we have now in loops, we can start to plot the path. So, looking at this, I would say with the next one we'd be moving forwards, forwards. Then we're going to have to rotate and rotate round to the right, forwards, forwards. Now you can see that I'm writing this in a vertical algorithm and I may need some more space, so students will be adjusting where they position some of these cards. Students can write horizontally as well, or some of them even write in the same shape as the path, and it doesn't matter as long as they can carefully read the instructions afterwards. So the next one, I'm going to go right again, forwards, forwards, and then I'm going to go left, forwards, forwards, and then once again I'm going to go left again, and then forward, forward. So once you've actually written an algorithm, the students will obviously be working together with this. You can see that this is a very, very long algorithm. It's so much so it's going off the video. When they're ready to test and trial, what we do is we get them to place this play run icon, which matches what is in the digital app. So a similar button is there for when they want to actually test and trial the programs that they input into the app. This is placed at the very beginning where they're starting to read the instructions from. And this is quite important because otherwise we don't know which end they're going to read from. Is it going to be read from top to bottom, or is it going to be read from bottom to top? Same as if they go horizontally, is it going to be read from left to right or right to left? So by placing this at the top, we know that they're going to start at the top here. And what we do then is get a student to read through the commands and another student to follow. So hopefully, fingers crossed, this will work. Forward, 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 right turn, forward, forward, right turn, forward, forward, left turn, forward, forward, left turn, forward, forward. And so you can see I've been successful with the sequential algorithm. You can then get students to trial different routes. Is there a different way to solve the problem? And that's then exploring and expanding and showcasing that there's more than one way to actually solve something.